Hi guys, welcome back to the Art of Server. This video is part 6, the very last video in this series of videos where I test the power consumption of LSI HBA SAS controllers such as this 9201-16E. What you're looking at here is my HBA power consumption testing rig, and if you'd like to know more about this, I've made a separate video going over the details of this setup. I'll leave a link to that video in the corner right here. In this final video, I'm testing the power consumption of 16 external SAS link controllers. The controllers covered in this video will start with the 9201-16E, the 9202-16E, the 9206-16E, the 9302-16E, the 9305-16E, and finally the 9400-16E. This spans 5 generations of LSI HBA controllers. I'm skipping over the first gen, and I don't have any of the newer 7th and 8th gen external port HBAs as they are out of my price range. Now, to do a quick recap on how I'm testing the power consumption, the HBA is plugged into this interposer board from Elmore Labs. This board cuts off power from the motherboard and supplies it through this 6-pin PCIe power cable, which is metered over here on this device, the Elmore Labs PMD2. This line here that says PCIe will indicate the power consumed by the SAS controller. In one of the previous videos, someone commented about 3.3 volt power, and the answer is yes. The PCIe interposer board does convert the 12 volt to 3.3 volt and 3.3 volt auxiliary. So all power to the card is coming through this cable and the PMD2. I will keep a camera on the PMD2 so you can see this reading while I'm conducting the tests. Now, to see how the power consumption is affected by I/O load, we're also going to run a FIO 4K random read load test using these 8 SAS3 SSDs. These SSDs will allow us to generate a load of roughly 1.5 million IOPS. This should be an appropriate I/O load for the controllers we have today. Now, if you're interested in the power consumption of other LSI HBAs not covered in this video, check out my previous videos in this series. I'll leave links to those videos down in the description. Now, fair warning, this video covers a lot of ground, and so it's going to be quite long. I don't expect anyone to watch this from beginning to end, so if you only want to see the results for a specific card, use the timestamps down in the description and skip to whichever tests interest you the most. Or you can skip to the summary discussion to just see all the results and jump back to a specific test if you want to see what actually happened during testing. Basically, use the timestamps however you see fit. I'm not here to get long view durations. I just want to provide information about these LSI HBA controllers that aren't readily available. That said, this series has consumed many hours, and so if you appreciate this content, please hit the like button and share this series of videos where it can best serve its purpose. So on that note, thank you all for your support, and let's get started. Alright guys, so we're booted up with the 9201-16E card. So let me go ahead and first just show you guys that we can see this card. So with SAS to Flash, you can see that this is a SAS 2116 based controller, which is the chipset that's on the SAS 9201-16E. And if I run LSSCSI, we should be able to see all 8 drives, SDB through SDI. All right, so right now we are idling at about 13 watts. So that's what we're seeing at idle. And let's go ahead and run the FIO workload on this. All right. Oh, I guess for completeness sake, let me show you guys, in case you're new to this series, I want to show you the FIO script that I'm using. So if you want to see the settings that I'm using for this load test, pause the video right here and you can take a look at that. All right, so at the end of this configuration file, I have listed SDB through SDI, so that's the workload is going to be on all 8 of those SSDs simultaneously, and then the results will be aggregated. And that's why I have the group reporting. Okay, so let's get ready. All right, so we are seeing 13 watts at idle, and here we go with the load. All right, so it jumped up to 15 watts under load. We're seeing about 353,000 IOPS right now, still at 15 watts. We're at 365,000 IOPS. Getting roughly about 1.4 gigabytes a second, I think, as far as the bandwidth goes. I got 12 more seconds. We're still at 15 watts. And we're almost done. All right, we're done. And it's now back to 13 watts. So it looks like the power fluctuates from an idle 13 watts to 15 watts under load. And the number we're seeing here, average IOPS during that run was 361,000 IOPS. And we got roughly 1.4, almost 1.5 gigabytes per second. All right, let me go ahead and shut down, and we'll move on to the next card. All right, guys, so this is the 9202-16E card. It's a rather older card, but it has two SAS 2008 controllers on board with a PLX PCIe switch that connects the two of them into a PCIe by 16 connector. Now, with that said, this connector, although it is physically by 16, the number of PCI lanes in that slot is only by 8, so we're only going to get half the bandwidth on this. So just keep that in mind in the testing. All right, so we're booted up with a 9202-16E, and right now we're seeing it idle at about 15 watts. So this is the card that has two SAS 2008 chipsets, and I can show you that by running SAS to flash list all words, I think will show. So yeah, you'll see that there's controller 1 is a SAS 2008 as part of the 9202-16E, and then the second controller, same thing. So they're basically two chipsets, and they're glued together through a PLX chip. And I want to show you something that I always do with these controllers. So I have this PCI lane testing script that I wrote that makes it a little bit easier for me to test the PCI lanes and stuff like that. So -V is for vendor, and so I'm going to test everything that is LSI based. And so it finds the SAS 2008 chipset, it checks for the PCI speed and width and make sure that it's okay. So you can see that both controllers are passed as okay. However, with a card like this, this isn't the complete test. And this is something that I think a lot of people miss when they are using these cards, is that they check the LSI controller chip, but they forget to check the PCIe switch, because that's ultimately what connects both chips to your PCIe route. And if that's not working properly, then you're going to have some problems. And so I've had people who have contacted me saying, hey, my 9202 or my 9206-16E or even the 9300-16i card, they think everything's working, but somehow when they run a throughput test or something like that, something isn't working quite right. And a lot of times it turns out that some of the PCI lanes were not set up correctly, or they were damaged, right? So I also do a PLX test. So this is for the PLX vendor, which is the company that's now owned by Broadcom that makes the PCIe switches. And so you'll see that two of these connections, so there's three of them, and that's because one connection is to one of the chips, the other connection is to the second chip, and that first connection is to the rest of the system. And you'll see that it shows as failed, and that's because this is supposed to connect at by 16, and it's noticing that it's not fully connected by 16. It's only seeing 8 SAS lanes, and so, or sorry, 8 PCI lanes, and so it's indicating that that has failed. So, and which I mentioned to you guys when I was installing this card, that we don't have enough PCI lanes in that slot for this card, and so this is expected. We'll just use it as is and see what kind of numbers we get. So anyway, if you guys are ever working with a card that's a dual chip card with a PLX switch, make sure you test the PCI lane connections and make sure that that's all as expected. And in this case, this is as expected because the motherboard doesn't have 16 lanes in that slot. Okay, so anyway, it looks like everything is as expected. The chips on the card are connecting to the switch. The switch is connected to the motherboard. Everything is as expected. And let me just show you one of the chips. So it is SAS 2008, and here is the version of the firmware and all that stuff. So you get a sense of what's on it. And it's the same thing for the second chip as well. Same firmware version and all that stuff. Okay, now I've connected the cables so that half of my SSDs are on one chip. So 4 of them are on one chip, and the other 4 are connected to the other chip. And that way I can make the most, under the load test, I can make the most of the card by using both chips. So if I run lsscsi, oops, I gotta spell it right, lsscsi, okay, you'll see that I have the same 8 SSDs, but they're showing up a little bit differently. I have B, C, D, E, and then F, G, H, I. So that's okay. So that's SDB through SDI basically. All right. So I need to run the 4K test that goes from SDB to SDI. Okay. So before we get started, let's take another look. We are idling at 15 watts, more or less, occasionally into the 16 watt range, but I think it's spending more time at 15 watts. So let's just call it 15 watts. And now under load. All right, so under load, it's kind of 17 watt-ish, between 16 and 17 watts. And we're seeing roughly 792,000 IOPS right now, with a total bandwidth of about a little over 3 gigabytes. All right, we're almost done. We got 7 seconds to go. We are still around 16 to 17 watts, so it's a high 16, low 17 watts, and we are done. Okay, so we got an average IOPS of 780, I'm gonna just call that 85, so 785,000 IOPS. And we had a bandwidth of roughly 3.2 gigabytes or so. All right, so let me go ahead and shut this down, and we'll move on to the next card. All right, so this is the next card. This is the 9206-16E. It has two 2308 SAS 2308 chipsets and a PLX switch that connects both of them together. And you'll notice that this is only a PCIe by 8 connector here, and but this supports PCIe 3.0, so even with by 8, it has almost the same bandwidth as the previous card, which was a PCIe 2.0 card by 16. This is actually one of the hottest running cards, and there's a design flaw actually, I think, with this card, and that is the heatsink retention pins right here. These are made out of plastic, and one thing that I've seen myself, as well as many of my customers have noticed, is that if you don't cool this card correctly, or if it's been exposed to a lot of heat because this card gets so hot, that these plastic pins basically get brittle and then they just crack. And so this can happen while the card is running in your server, and you won't even notice it because the pins will just crack and fall apart, and the heat sinks get detached, and then at some point your processors get overheated and the card fails. And so that has happened to quite a few people, and I've suggested that you can actually replace these pins with brass pins that don't obviously crack under heat. So anyway, if you are running one of these cards long term, I do recommend that you get some brass pins to hold these heat sinks and maybe change out the thermal paste and that kind of stuff. But anyway, let's go ahead and get this installed. Okay, so we are now booted up with the 9206-16E, and let me just show you guys that the controller is online. And so there are two SAS 2308 chipsets that are active on this 9206-16E card. And if I
show you the individual controllers, you can see SAS 2308, part of the 9206-16E, and this is the firmware version, which is the latest available for this chipset. And same thing if I show you the second controller, right? So everything appears to be there, and I'm going to also show you the PCIe connections. And so here I'm testing the PCIe connections of all LSI chips on the system. And so here's the first 2308. It is PCIe 3.0 by 8, and so that's good. And the second one is basically exactly the same thing. Now, of course, those are connected to the PLX chip, so we also have to test out the PLX chip. All right, so here we can see that the PLX chip has 3 connections. One is PCIe 3.0 by 8, another is PCIe 3.0 by 8, and a third is also PCIe 3.0 by 8. So I believe the first one is basically the PLX chip's connection to the motherboard, and then these other 2 are the connections to those SAS 2308 chipsets. So everything is connecting correctly at the right speeds, at the right number of lanes. And then of course there's this other thing that basically is not connected, and I'm not sure what that is. There might be extra PCIe lanes on that chip that are not being utilized. Okay, so basically everything looks like it's working correctly, and if I run lsscsi, we should see the SSDs connected. And so here are the 8 SSDs connected as SDA through SDH. And the way I've connected these, by the way, so let's see, maybe I can run this to show you. Yeah, okay, so the way I've connected these is 4 of those SSDs are connected to one chip, and then the other 4 are connected to the other chip, and that way I can spread the load across both controller chips just to even out the load and basically get the most I can out of this controller when we do the load test. All right, so that's where we're at. And taking a look at the idle power right now, this card is sitting at 26 watts. Wow, that is probably the most that I've seen so far in all these tests, that this card, and so it's no wonder that this card gets so hot, because this is basically at idle and it's not doing anything, and it's consuming 26 watts right now. So wow, that's more than the 9300-16i card. So yeah, this is definitely a power hungry card, and it also gets very, very hot. So if you're ever pulling one of these cards out of a server that's been running, you do have to be careful. You can burn your hands if you touch the heat sinks. They are extremely hot sometimes, and so I recommend that you let it cool off, or just touch it briefly to make sure it's not too hot before you grab the card. Okay, so let's set up. So the drives are SDA through SDH, so we're going to use A through H. All right, so let's get ready. 26 watts right now at idle, and now under load. All right, so under load it's about 28, hovering between 27 and 28 watts. We're seeing about 850,000 IOPS. Well, it popped up a little bit to 880,000 IOPS. So definitely much better performing than the previous generation 9202. Got 18 seconds to go. Yep, and it's still at 28 watts. Yeah, this is definitely a very power hungry card. It's showing roughly about 3.4 gigabytes a second, but all right, so tests are done. It's now back down to 26 watts, and the average IOPS that we got was 880,521, and for bandwidth we got about 3.6 gigabytes per second basically. All right, so yeah, this is definitely one of the more power hungry cards here, and yeah, it's no surprise how hot it gets. Okay, let's shut down and move on to the next one. Alright guys, so this is the next card we're going to test. This is the 9302-16E. This is also another dual chip
design. Although this has one giant heatsink, there are actually two controllers here, and they're based on the SAS 3008 chipset, so there's two SAS 3008s. This is similar to the 9300-16i, and the only difference, however, is that the PLX chip here makes a 6x16 connection to the system, so theoretically it provides you more bandwidth if you can use that. However, again, the motherboard we're using today does not have a PCIe lane, so we're going to see that connect only with 8 PCIe lanes instead of 16. Alright, let's go ahead and get this installed. Alright, so we're booted up, and this is a SAS 3 controller, so I'm using SAS 3 Flash to list all, and you can see that I have both SAS 3008 controllers here, and I'll list the first one. And so this is the version of firmware we're running. This is from the 9302-16E, and you'll see that we'll have the same thing on the second chip. Alright, so both controllers on that card appear to be working. Let's check out the PCI lanes. Alright, so both are, the chips itself are connected at PCIe 3.0 by 8. And again, this has a PLX chip, so we got to test that out as well. Alright, so two of these connections are okay, and that's probably because those are the ones connected to the chip. This one here is PCIe 3.0 by 8, and it's showing as failed because this is supposed to connect at by 16, and that's expected again because this motherboard's PCI slot does not have enough PCI lanes for that. Alright, but anyway, everything is as expected, and if I run LSSCSI, we see that we have 4 SSDs here and 4 SSDs here. If I run my port monitoring, you'll see I have 4 of those SSDs connecting at 12 gigabits. So remember, these are SAS 3 SSDs, and this is the first SAS 3 controller that we are testing out. So those SSDs are finally able to actually connect at 12 gigabits per second here. And I have 4 of them on one controller and the other 4 on the other controller, again, to spread the load out so that when we run the IO load test, we're utilizing both chips. All right. So right now, let's take a look. The card is idling at about 24 watts. So that is actually very similar to the 9300-16i that we've tested in prior video. And let's put this under load, and so it's SDB through SDI. All right, so we have it at 24 watts idle and now under load. All right, so it shot up to 26 watts. And we're seeing about 1.5 million IOPS. So I think that's almost at the limit of what those SSDs can do. And we're seeing over 6 gigabytes per second transfer speeds. So this card is definitely very fast and fully capable of handling the full IOPS capacity of those 8 SSDs. All right, we're done, and power is now down to 24 watts again. So it basically went from 24 watts to about 26 watts, and the average IOPS we got, where is that, right here, is about 1.56 million IOPS, and a total transfer speed or the bandwidth of about 6.4 gigabytes per second. All right, so definitely one of the more impressive cards that we've tested so far, and the power consumption was actually better than, well, a few watts better than the 9206-16E. All right, let's go ahead and shut this down and move on to the next one. All right, so here is the 9305-16i. This is based on the I believe it's the 3216 chipset. And yeah, this is going to be the next one that we're going to test out. Alright, so we're booted up with the 9305-16i card installed. And right now, if we're looking at the PMD2, you can see that this card is idling at 12 watts. So after the last several cards that were fairly high power consuming cards, this is nice. This is a nice change to see something that's under 20 watts here. So yeah, if you're after power efficiency or low power, you're after a low power card, the last 2 or 3 cards were probably not your preferred choices. But this one seems to be okay. This is all right. Let's just get into this thing. SAS 3 flash. All right, so this is based on the SAS 3216 chipset, and this is, as mentioned, the 9305-16E. This is a 16-lane card, but unlike the last 3 cards, this is a single chip design, and I think we can see that the power consumption is much lower here because of that single chip design. All right, well, you can see the firmware version, all that stuff, so I think that's good to go. And if you just like, all right, let's show you the PCIe lane. It's PCIe 3.0 by 8, and that is all good to go. All right, and let's see if we see all SSDs. So we have the 8 SSDs showing up as SDB through SDI, so that means we need to run this one. Okay. All right, so we got 12 watts at idle, and now under load it moved to 13 watts, so just a little bit higher. And we're seeing 1,300, 1,400 IOPS. Or sorry, I'm not. That's in kilos, so that's 1.4 million IOPS right now. So that's actually fairly closely comparable to the 9302, for example, that we tested prior to this card. And the power consumption is up to 13 watts right now. So it's basically half the power consumption of the 9302 for almost the same performance. It's just maybe slightly lower. All right, so we are done. We're back to 12 watts. So yeah, so let's see what did we get at the end here. We have 1.428 million IOPS, and we got about roughly like 5.8ish gigabytes per second. So this is just slightly less than the numbers for the 9302-16E, but we are consuming basically roughly half the power consumption. So the last card at idle was 24 watts. This is sitting at 12 watts. So yeah, that's literally half the power consumption for, say, like 90% of the performance. So I think this is a pretty compelling option to go with if you want a little bit more power efficiency and willing to sacrifice a little bit of the performance. All right, let me go ahead and shut this down, and we'll move on to the very last card. All right, so here is the last card we're going to test today. This is the 9400-16i, and this card here is the first generation based on the ARM architecture, and I believe Broadcom made that architectural move because they were concerned about the creeping power consumption of their HBA controllers, and so hopefully we'll be able to see even better energy efficiency with this generation. Alright guys, so finally booted up here with the 9400-16E, and unfortunately, as with the other 9400 series cards that I've previously tested, this card would not boot up with that PCIe interposer board without forcing the link speed to PCIe 2.0. So I set the motherboard to force that slot into PCIe 2.0, and the card shows up, I believe. So I'll show you right now. Yep, so here it is, right? Let me scroll up a little bit. We can see here is the 9400-16E, and there's the firmware versions that you can see right there that I believe is the latest and greatest for this generation. And then of course down here in the PD list we see the 8 SSDs connected to it. All right, so everything seems to be working okay, but if I test the PCIe lanes on this LSI card, you'll see that it is linking at 2 gigabits or PCIe 2.0 speeds. Okay, so unfortunately that's the only way we can get this to work while trying to measure its power consumption. And so right now it is consuming about 8 watts, which is really pretty incredible. That is by far the lowest idle power rating of all the cards we've tested so far in this video. So yeah, if you want something, if you need a 16 external ports and you want the lowest possible idle power consumption, this is it, right? Okay, so as mentioned, we have the 8 SSDs showing up as drive SDA through SDH. And so I will run this file script to generate the load on all 8 of those SSDs. All right, so right now we are at 8 watts at idle and now under load. Okay, so about 9 watts. Not much changes. We're looking at about 826,000 IOPS right now, with bandwidth of about 3.2 gigabytes per second. So this is not the most high performing option for sure, but again, that may be because we're limited to PCIe 2.0 speeds right now. So I'm going to rerun this test with the card in a normal PCI slot so we can see its full performance. All right, so we're back down to 8 watts after the test concluded. All right, so let's write down these numbers here. I've got 800 and 18,922, so about 808, let's say 819,000 IOPS, and the throughput was about 3,349 megabytes per second. All right, so let's go ahead and retest this card. We got the power rating. I'll retest this card in a normal PCI slot where we won't have a way to measure the power consumption, but let's just re-examine these numbers without the PCIe 2.0 issue. All right, so I've got the card moved to another slot without using the Elmore Labs interposer, so it should run normally now. So if I test the PCI link, you'll see that it's at 8 gigatransfers per second. So that's PCIe 3.0. So that's the way it should be. And if I run store CLI, I should be able to see this card no problem, and as well as all the SSDs. But let's just scroll up here. So yep, 9400-16i, right? No problem. Here's the firmware versions. Okay, so this is the way the card should work. So let's now run, let's see here. So it's SDB through SDI, so let's run the file load from B to I. All right, let's go. All right, so this is much better. We're hitting about 1.5 million IOPS already right out the gate. So definitely putting that card in PCIe 2.0
mode does hinder its performance pretty significantly. Unfortunately, I can't measure the power consumption under these conditions, but I suspect it's probably not too different, just as with the other tests of these 9400 series cards. But yeah, we are getting easily sustaining 1.5 million IOPS and over 6 gigabytes per second in bandwidth. So really, this is faster than the 9305-16i. And yeah, we're done here. So all right, let's look at these numbers. We got basically 1.567 million IOPS, and we got 6,409 megabytes per second. So that is the highest throughput that we've gotten today of all. I'm looking at the other numbers that were recorded for this video, and that's the highest throughput and highest. Is it the highest IOPS? It is the highest IOPS as well. So yeah, I think of all the cards, this is the most energy efficient and highest performing. So it's just a little bit finicky about the PCI lanes. So long as you're not using it in a interposer board to try to measure the power consumption, you'll do just fine. But I think this is probably the best option in terms of performance and energy efficiency. All right, let's wrap up here. I'm going to put all the results in a table, and then we'll kind of have a summary discussion of all the results. All right, so here is a table of all the results we've collected during this video. And we'll start the discussion with the SAS 2116 chipset, which is the 9201-16E card. And this is basically the external port equivalent of the 9201-16i that we tested in part 2 of this series. So this is a PCIe 2.0 card, and it supports SAS2 6 gigabits SAS links. And it has an IOPS rating of 430,000 IOPS per LSI documentation, and we measured 362,000 IOPS. So we're coming in a little bit short of that specification for some reason. And that's, it was pretty much the same thing with the 9201-16i version as well. So all the numbers here are pretty much consistent with the internal version of this card. For bandwidth, we got 1,480 megabytes per second, and the nominal power rating was 15.36 watts with a worst case rating of 24.94 watts. And our measurements showed 13 watts at idle and 15 watts under load. And so I think this is pretty much spot on. If you think of the 15 watts as basically this, same as the 15.36 watts, as our measurement device doesn't have higher resolution. So I think the specifications are pretty spot on. But for whatever reason, the IOPS came in a little bit short. But this is exactly what we saw as well previously with the Dash 16i version of this card. So it is what it is, but at least it is consistent. All right, moving on to the next card. This is the dual chip design SAS 2008, known as the 9202-16E. This is also a PCIe 2.0 card, but it has 16 lanes and supports SAS2 6 gigabit. It is a dual chip design with a PLX switch that glues those two chips together and connects it to the PCI bus. This card has an official rating of over 700,000 IOPS, and we ended up measuring 785,000 IOPS, which is a little bit higher than the specification. And this has been pretty consistent throughout all the testing that we've done. Pretty much all the SAS 2008 based cards exceeded their expected specifications when we tested them. So I don't know why that is, but it's kind of cool that one of these older cards seems to perform better than you expect. All right, so for bandwidth, we got 3,210 megabytes per second, and the typical power rating for this card was 17 watts per the documentation, and I think we were pretty spot on with that as well. Our measurements showed 15 watts at idle and exactly 17 watts under a load. So I think that's pretty much what you would expect. And, as far as the IOPS being higher than the specification, that seems to be consistent across the board with all these SAS 2008 controllers. So that's kind of cool. Like I said, the SAS 2008, I've said this many times before in previous videos and other videos, It's one of my favorite generation of LSI HBAs. I know it's ancient, PCIe 2.0 and all that stuff, and you wouldn't want to use it with any kind of SSDs. But honestly, like if you're running hard drives, this is a great option. So I love those cards. All right, so let's move on to the next one. So this is also another dual chip design based on a newer generation chip, the SAS 2308, and this is the 9206-16E card. So with the new chipset, this card supports PCIe 3.0, this time not by 16 but by 8. And again, it's still a SAS 2 6 gigabit card. Again, dual controller chips glued together with a PLX switch. Now, the official IOPS rating for this card is over 1 million IOPS, but our measurements showed something a little bit short of that, basically about 12% short of that at 881,000 IOPS. And this is, again, for whatever reason, has been fairly consistent with all the other 2308 cards that we've tested in this series of videos. The 2308s always seem to come in a little bit short on the IOPS for some reason, at least with the testing that we're doing. So I don't know why that is, but it has been consistently so. For bandwidth, we got 3,600 megabytes per second, and the nominal power rating per documentation was 25.8 watts. We came in at 26 watts under idle, and with the load that we generated, it went up to 28 watts. So if you're comparing this to idle power, I guess it's pretty dead on, but under load, it seems to be higher than the 25.8 watts, by about 2.2 watts, right? So so this was one of the more power hungry. In fact, of all the cards tested for this video, this is the most power hungry card. Okay, let's move on to the next one. So the next one is, again, another dual chip design, but using the SAS 3008 chipset. So this is the 9302-16E. The SAS 3008 chipset brings in support for SAS 3 12 gigabits per second SAS link speeds. This is a PCIe 3.0 by 16 card, but as mentioned during the testing, the motherboard doesn't have 16 lanes for that slot, and so we're running it at 8 PCIe lanes. I made a slight mistake earlier in this video. I said that near the beginning of the video, I said that the 8 SSDs that we have can generate a load of about 1.5 million IOPS, and indeed that's what we see. We got a load of 1.56 million IOPS here, but the thing that I made a mistake about was saying that this would be an appropriate load for all the cards that we're testing in this video, and I think I wasn't thinking straight. For whatever reason, I was thinking of this card as a SAS 3008 card, but forgetting the fact that it's a dual SAS 3008 card. And so a SAS 3008 chip can do roughly about 1.4, somewhere from 1 to 1.4 million IOPS. And so I thought, okay, 1.5 million IOP capability of those SSDs should match that just fine. But I, temporarily forgot this is a dual chip design. And so this actually handles a lot more. The official rating was 2.8 million IOPS. And we're coming at 1.56 million, which I think is really just the limitation of the SSDs. So we're not really pushing the limits of this card with those SSDs. We'd have to double the number of SSDs or something like that to really push the limits of this card. As for bandwidth numbers, we came in at 6,398 megabytes per second. But again, keeping in mind that this is running only with 8 PCIe lanes instead of 16. And I kind of suspect that if we had 8 more of those SSDs, so a total of 16 of those SSDs, and we had this in a by 16 slot with 16 PCIe lanes, I think we could easily exceed the numbers that we got here. Okay. Now, as far as power consumption goes, the specification says a nominal power rating of 30.0 watts, a very exact number there. But and this is, again, consistent with all the other testing we've done. A lot of these SAS 3008 controllers seem to come in lower as far as the power consumption goes than what is documented in Broadcom's documentation. So we came in with an idle power of 24 watts, and under load, we got 26 watts. Now, you could say that we weren't really pushing the limits of this controller, the dual chipsets, and so maybe under a heavier load, the power consumption might creep up a little bit. But, honestly, I don't really think there is going to be a huge variation, because for other SAS 3008 controllers where we're able to push its limits, we saw an increase of 1 to 2 watts, So this is fairly consistent. I think even if we push this to 2.8 million IOPS, I think you're going to see, something not too far from 26 watts under load. Oh, actually, one thing I wanted to mention that I thought was really interesting, I can't explain it, but I noticed it as I was looking at these results, is that the SAS 3008 chipset has a higher power rating than the SAS 2308 chipset. And when we were testing these cards, other cards, like the Dash 8i cards, using these chipsets, the 3008 chipset usually consumes more power than the 2308 chipset. However, in this testing that we've just done, for whatever reason, the 9302-16E, if you notice here, is running about 2 watts less than the 9206-16E. And consistently so, even under load, it seems to be running 2 watt less. So I can't really explain that. I thought that was kind of a very interesting result. And I mean, it's good for the 9302-16E, saying that basically it's a little bit, less power hungry than its predecessor. But that's kind of unexpected, because I would have expected the reverse, actually, that the 9206-16E would consume a couple watts less than the 9302-16E. But that's what we got. So, I can't mess with the facts. All right, moving on. So the next card is based on the SAS 3216 chipset. This is the 9305-16E. This was basically Broadcom's kind of a minor upgrade from the 3000 series. So it still supports a SAS 3 12 gigabits per second, supports PCIe 3.0. But as you notice with the SAS 3008 controllers, a lot of these controllers, when they wanted more not PCIe, but SAS lanes, they went to the dual chip design architecture. And of course, one of the drawbacks of that, of course, is the power consumption, right? So with the 3200 series chipsets, Broadcom basically consolidated a lot of these. They started building some chips that had more SAS lanes, right? And so you can get the 9305-16i, 9305-16E, also the 9305-24i, which had 24 SAS lanes, right? So we expect that this chipset, being a single chip design, to consume less power, and indeed that's what we're going to see here. So let's go over these results. The IOPS came in at 1.43 million IOPS, whereas the specification says greater than 1.5 million IOPS. And so I think we were pretty close to that mark, maybe coming in a little bit less, but I'd say close enough, right? For bandwidth, we got 5,841 megabytes per second. And for the power spec, the documentation says the typical power consumption of this card is 13 watts. We're pretty much seeing, our measurements were, I would say, dead on. We got a 12 watt at idle and 13 watts under load. And I believe that we are pushing the limits of this chip. So I do think that, the 13 watts is truly under 100% load. And I say that because even though we didn't meet the 1.5 million, we know that those SSDs can push 1.5 million because we got that result prior. And so this 1.43 million, I think, is the limitation of this chipset. All right, so that's the 9305-16E. And yes, it definitely came in. I mean, if you look at the power rating, basically, it came in at half of the previous 9302-16E card, right? The 12 watts versus the 24 watts, the 13 watts versus the 26 watts. Now, of course, the performance of the 9302-16E, I think, can be pushed further, much further than this card. But, if you don't need all that performance and you rather save some power, I think the 9305-16E makes a great candidate for an external 16-lane HBA. All right, so moving on to the next one, which is based on the SAS 3416 chipset. This is the 9400-16E. This is the first generation where Broadcom introduces the ARM architecture-based IOC controllers. And of course, I think this is not officially confirmed, but I think anybody looking at the progression of these architectures can tell that the power consumption kept creeping up over time. And I think there was probably a motivation to go to ARM in order to create more energy efficient controller chips. Now, this is still a PCIe 3.0 card, but we were having problems running this in PCIe 3.0 mode using that interposer board that measures the power. So we had to set this at PCIe 2.0 for this test in order to measure the power. So, okay, so we got 819,000 IOPS, and this card, this generation of card, and I've mentioned this before, this generation of card, Broadcom somehow was very reluctant to mention an exact IOPS performance number, but they would say like, oh, you know, it's a little bit better than the previous generation. So yeah, so that's what they've said. That's why I've written this as the spec being, you know, greater than 1 million IOPS, maybe, question mark, okay? I think, you know, the target would be somewhere comparing this generation to, say, the 3216 at greater than 1.5 million IOPS, or the 3008, which, you know, in this case would be like half of that, so maybe like 1.4. So I think if we get somewhere around 1.4 to 1.5 million IOPS for this 9400 card, I think we would be meeting specification. But of course, as you can see, we did not, and I think that's not because of the card not performing, but because the card is set to run in PCIe 2.0 mode. As you can see by the bandwidth numbers, we are limited at about 3,349 megabytes per second, and I think that's really kind of hitting the limits of PCIe 2.0 by 8, and so therefore once we hit that limit, we couldn't push more IOPS into this card. All right, so the typical power consumption rating is 11.18 watts, and our measurements showed something a little bit less than that at 8 watts under idle and under load. And although this was not full load because we couldn't get there due to the PCIe 2.0 limitation, it showed up as 9 watts. Now, that said, I actually think these numbers are probably spot on, meaning that one could question, because we're running this in PCIe 2.0 mode and we weren't really able to push its IOPS limits, one could question whether this power measurement that we took would be the same if it were to run under PCIe 3.0 mode and we were actually pushing the IOPS limits closer to the 1.5 million range, right? But that said, remember, this card is equivalent to the 9400-16i, and we tested that card in, I think, part 2 in the series, and we basically got the same exact power numbers. And in that case, with the 9400-16i in part 2, we didn't have problems running that in this interposer board for some reason. So we were actually able to run it in PCIe 3.0 mode and get the power measurements, and we got the exact same numbers. Okay, so that kind of gives me some confidence to say that I think, yes, if you were running this card, you know, in PCIe 3.0 mode, you're basically going to get very similar numbers to the power measurements that we took here. So we have very, very energy efficient card compared to all the other ones, especially the last 3 generations. If you're looking for energy efficient, you want 16 external ports, and you want the best performance, I think this is going to be the card to choose. On that topic of performance, so we reran the tests, the FIO load test with this card in a normal PCI slot without the interposer board. We're not going to measure the power anymore, and just let it run natively at PCIe 3.0. And indeed, that really let this card shine. As you can see, the power, well, let's go to the IOPS first. The IOPS rating came out at 1.57 million IOPS. And again, you know, the documentation was saying basically this should be a little bit better. And indeed, if you look at this, 1.57 million IOPS is better than the, you know, 1.5 million of the 3216 series, and better than the 1.4 million IOPS of the 3008 series, right? So this card definitely, I think, is the highest performing. I mean, if you look at the IOPS numbers that we got, at least in this batch of testing, this was indeed the highest number. And the same goes with the bandwidth number. So for the bandwidth, we got 6,409 megabytes per second, and this is indeed the highest number that we got in our measurements with this batch of cards. Now, that said, I think the 9302-16E could perform better if we had more SSDs and we were running it in a by 16 slot. So, all right, that's it for the results of this video's testing. This 6-part series has taken quite a bit of time to do, not just in the actual recording and running the tests, but in the preparation and all this other stuff. So I really hope you guys enjoy these results, and I hope you find them helpful. And if you appreciate the work I've done, please give this video a thumbs up. And more importantly, if you know of anybody else who could benefit from this information, please share these videos with them. I'd like to get more people to benefit from the information I'm providing in these videos. So if you could, please go ahead and share this video where it's appropriate. Also, if you're new to this channel and you like this sort of stuff, consider subscribing to the channel. And if you want to support my channel, go check out my eBay store. I've got the best selection of pre-flash IT mode HBA SAS controllers for your ZFS, TrueNAS, and Unraid builds. Go check out the link down in the video description. Thank you very much. Have a nice day. Bye-bye.